Okay, in this first video, I'm going to start with the textbook reading that went with this unit because it does have some basic instruction on how to write what we would call a skeleton equation. That means writing a chemical equation, but not making it obey the laws of conservation and actually balancing the whole equation, but being able to write all of the chemical formulas for each of the reactants and the products and making sure that you can write the whole thing out with correct chemical formulas. So a lot of people got confused when I said you don't have to balance this reaction. I don't mean that you don't have to balance your formulas. What I mean is you don't have to balance your equation. So it's really important when you're reading chemistry language that you are paying close attention to the meanings of words. And this is why in your understanding section, I expect to see you paying close attention to making sure you can distinguish between different types of vocabulary terms and that you're comparing and contrasting them so that you can actually understand what makes them different and recognize them when you're reading. So, starting with this sample problem that was in the chapter, goes over how to write a skeleton equation, and they give you a pretty good reaction to start with. The only thing that you guys don't know yet is what hydrochloric acid is. Hydrochloric acid would be the molecular compound hydrogen chloride mixed with water. So that's how acids work. Is there a lot of them are actually molecular, but then you mix them with water and they become acid. So they're not really that much fun in their original form either, which is as a gas. I wouldn't breathe that in other words. All right, so basically hydrochloric acid, you don't need to know this right now. If I were to give this to you on a test question, I would tell you that it was mixed with water. You are going to put hydrochloric acid, and I'm going to put this in AQ because it's mixed with water to be an acid. Okay, plus solid sodium hydrogen carbonate. Okay, solid sodium hydrogen carbonate. Hydrogen carbonate is a polyatomic ion. So when you're reading a verbal description of a reaction and trying to translate it into an equation, you want to make sure you're breaking down the actual reading part of this so that you understand what you're looking at. So reacts with is a sign that you're adding the other ingredient in the reaction. So that's where your plus is going to go. And then sodium hydrogen carbonate is one compound. Okay, it's sodium, the indication that there's a metal here, and also what looks to me to be a polyatomic ion is going to tell me that this is an ionic compound. However, I'm clued into the fact that this is a polyatomic I'm not familiar with because it has too many gosh darn names. Okay, normally you would only see one name, nitrate, sulfate, phosphate. The fact that this is all together tells me that this is a polyatomic that I'm not familiar with. It's not one of the six I asked you to memorize. So you're going to go to table E, which you will be given on this next test, and you will look it up. Hydrogen carbonate looks like this, and it has a -1 charge. So I know from my experience balancing charges when I'm writing ionic formulas that this is going to be written one of each of these. Okay, even though this polyatomic is long and confusing, it comes as a set. Okay, you don't break them up. These guys, just think of you're buying something at the store and they're shrink wrapped together. That's how it comes. You're not allowed to take it apart. You have to buy it as a set or you can't have it at all. Sorry. All right, so I'm going to write the compound out, NaHCO3. Now I continue reading. The products formed, okay, in this case, the reading tells me that I'm about to talk about my products and that they've already been formed. So one of the reasons why I have my pet peeve is don't write equal signs is equal signs don't really have the same implications as an arrow. Okay, in chemistry, what that arrow means is that a process has occurred and that that process involved the breaking and forming of chemical bonds so that on the other side, an entirely new thing was made. This is not a math equation. While it has mathematical implications, it's not quite the same thing as saying these two things aren't equal to each other. They're not equal to each other in the same way that they would be in math. Right? So if I take in chemical equation, I have ingredients and I have something I made. So if you do this with a chemical reaction you would do at home, believe it or not, baking a cake is a chemical reaction for several reasons. You might put a chemical in there that makes the cake rise up and be fluffy. That's actually a chemical reaction. When you heat something and cook it, that's actually causing chemical reactions in the food. And that's why you cook it, because flour is disgusting if you just ate it the way it is. But when you mix it with the organic molecules found in eggs and butter and sugar, it becomes delicious. And when you put it in the oven, you're doing a chemical reaction. So that's a little bit different, right? A cake is not equal to flour, butter, and eggs. It's not like if I handed, so if that would be like if I handed you flour, butter, and eggs instead of a piece of cake, I think you would look at me a little funny, right? They're not equivalent to each other. So we don't use an equal sign. We use this arrow that describes this beautiful, wonderful process of a chemical change that gives us a rearranging of these elements until we get a different substance. And it really is pretty freaking cool. Okay. It's like magic. Um, all right. So on the other side, I'm not going to look at what reactants I wrote and then try and decide what to do with them. This sentence is going to tell me what to write. So according to this, I'm writing sodium chloride. The fact that this is written in front does not mean I write AQ in the front. Always subscripts that give phases. Oh, I forgot to put the S on this solid. Subscripts that tell me what phase or state this is in are always written after the compound. So sodium chloride, this is ionic, I would have to balance it, but probably you've memorized it, is just table salt. This is dissolved in water. AQ means dissolved in water, plus water. That's two hydrogen and an oxygen. I'm going to say that's liquid water, plus carbon dioxide. That one's molecular, so you're going to read the Greek prefixes. Carbon dioxide means two oxygen, and G for gas. And I'm done. Okay, so I'm reading. It's really a reading skill. You're doing reading, and then you're translating the names of chemical compounds into formulas. That's the key skill here. Okay, so usually what makes people mess up on this is you have not spent enough time practicing chemical notation for formulas. And so you're so confused by that still that your cognitive load is too high on this task. So I would go back to those foundational skills and make sure you're fluent. Please make sure you check the playlist of naming videos. There's really a lot of them at this point. I think I have maybe 5 or 6. Probably there will be more. So if naming is your problem, it's worth it for you to spend a little bit of time on that. But if you're mostly just working out a few little things, you shouldn't have to do it for too long. All right, so I've got reactants on the left-hand side of my arrow. I've got products on the right-hand side of my arrow. And I did not balance this equation. So that's just how to write a chemical equation. Let's see if we can find another example. I don't know if they gave us any. So geez, you guys, they went over it in the textbook reading too. It's not just like you didn't get it out of my slideshow. Here's a list of all the symbols. They were given to you also. In fact, they gave you more than I did. I didn't really want to get you into like starting to talk about what that looks like when it's heat and that kind of stuff. But we did go over arrows, pluses, solid, liquid, gas, and aqueous. So they go over this in quite a bit of detail. Right? What if I take this word equation, methane plus oxygen and carbon dioxide, and try and turn that into a chemical formula? Now, at this point in the game, you are not supposed to know. I mean, I will bring it up many, many times because sooner or later, you and methane are going to have to be familiar with each other. However, methane is an organic name, and you haven't learned how to name organic molecules yet. But methane is a molecule that's going to be really important to us through many, many topics. It's also just really important to you right now. Number one, it's natural gas. It's used to run the furnace in your house. It's used most likely in your stove. And in this world of, trying to decide whether or not fossil fuels continue to be a safe choice for us to use, natural gas, methane, is a really important part of human civilization. So you should know what it is. But in my problems, I would refer to it by its other chemical name, which would be carbon tetrahydride. And that's just so that you can figure out the formula without knowing chemical nomenclature from an organic perspective. So I'm going to write CH4 plus oxygen. Now, what background knowledge do you have to know to make sure you get this right? Oxygen is a diatomic gas. It's one of 7 that you unfortunately do have to memorize or have some trick for remembering. That's a fluency task. Understanding what I mean by diatomic is an understanding task. An application task for this is, can you remember to write it as O2 when you're writing a formula? Okay, or even just later, this is going to come up in calculations, whether or not you picked up on the fact that there's 2 oxygen. Okay, carbon dioxide, I'm reading the formula and translating it. Carbon dioxide, this is a molecular compound. It has a Greek prefix that says 2 oxygen, and water is H2O. I will sometimes just even put dihydrogen monoxide or dihydrogen oxide, just to make sure that you are clear about what you should be writing. That is the correct chemical name for water. But you'll see commonly everybody just says water in a lot of these. Okay, so this is a pretty straightforward process. If you are still having trouble with it, you want to practice either your reading skills or your chemical formula writing skills. So in the next video, what I'm going to do is I'm going to go over in detail one of the quiz practice, and I'm going to go ahead and balance all of those reactions while we're doing it. So get ready for that video. You're going to need to get your notebook out and probably pause me a lot. Right? That was a basic rundown of writing chemical formulas.